Hello everyone, welcome back to our channel Get Geomatics Engineering. In this channel we shall learn and explore geomatics engineering related domain, and today we are going to start a new topic, that is GIS database system. So I shall start with database first and how it is interrelated with GIS, that I shall explore in this video. So let us start. So I am starting with the basic database. The database is a high level description of the structure of any database. So spatial database are a specific type of database. So from the database I mainly concerned about the spatial database and something about the non-spatial database, that how this spatial database is connected to the non-spatial database. In non-spatial database we shall see the attributes, and we shall see that how this spatial database is connected to that attribute. So what are the features of databases? So you can see the features of databases, that data should be independent, integrated, and database should be flexible enough to cater various types of data and easily accessible, and it can cater a huge amount of information. So to cater these features, the database has to have some properties. So what are those properties? Those are mainly named as ACID properties, ACID. A for atomicity and C for consistency, isolation and durability. So atomicity refers to the integrity of the database. So what are the database properties do actually? They cater the features of the databases that are properly there or not. So for that you have to maintain the database properties to make one database management system. So then what are the non-spatial databases? That are mainly the attribute data. So what are the data types? Boolean, nominal, ordinal, integer, real and topological. But for our GIS scenario we mainly use the ratio or proportional attributes, interval data and ordinal and nominal data. These complex attributes are mainly based on those simple data types. So what is ratio or proportional attributes? Those are actually the length and area of any structure. Like if here is some polygon is here, and what is the area of that with respect to the real world. So based on the scale we can easily measure it. Suppose the scale is 1:10,000. So we can easily calculate the area of this based on that scale. So you can easily find out in the scale chapter that has already covered. And then the interval data. Suppose there is one map. The map represents the population of that area. So population is like something yellow, black color is representing 2000 to 10,000 population, and any other color is representing some other population. So that interval is represented based on the interval attribute is represented in that map. Another one is ordinal or nominal data, that air quality. Suppose the air quality is good or bad, so based on that the map is created. So if air quality is good, then it is represented as green, or if air quality is bad, then it is represented as the red one. So based on that the nominal attribute table is created. So these are the basic attribute data that are related to the GIS. Here one of the important thing that you have to remember, that ratio attribute data is the most accurate attribute data, because you can see that there is the original data that representing the earth surface. So that is why it is the most accurate data attribute data. Then the interval data, it's representing an interval, that the data can be from this to this, a range, in a range. So that is less accurate than the ratio or proportional attribute. And another one is the ordinal or nominal data, that is representing that is good or bad, something like that. So it is not representing a particular data or a particular property of that properly. So that is why it is the least accurate attribute table. Now what is DBMS? DBMS, it's a huge topic, and it can be covered in various domains like computer science domains and GIS domains. So I shall not get into details of DBMS because that is not in our syllabus. So what I shall cover, what is the basic DBMS is. So DBMS is a software application designed to organize the efficient and effective storage and access of data. A database is created, and it is an interrelated database based on any type of data structure. It may be hierarchical data structure, network. So I shall come into that, what are the types of databases structures. So any type of data structure is created, and the programmer has to create the database structure in such a way that anybody can query any based on SQL language or no SQL language, that it can be the data can be fetched easily in that system. So that is the main purpose of this DBMS, that database management system. So in the next thing is the types of database structures in DBMS. So one is hierarchical database structure. So what happens in the hierarchical database structure? So that is actually based on the one to many relationship. Like from after the A happens, then B and C are related to A. So data have a parent child or one to many relation, then that is a hierarchical database structure. So, but in this case the redundancy will be higher, so it will create a complex network structure. So for that reason we have to go for the network database structure, in which the redundancy is lesser than the hierarchical database structure. Here the relationship is many to many relationships, like there is more than one parents for a single child. That is the basic concept of this network database structure. Like suppose C is dependent on A and B both. So that is how a database structure can be created. Another one is relational database structure. So it is the relational database structure is important because in relational database structure there is one tuple and row. So one tuple represents a particular ID. Suppose this is the ID of any student and this is the subject taken by the student, and there is the professor who are taking those subjects. There is one table based on ID, subject and professors, and this student may have many other parameters like the name of the student. So there is another table, ID and name. So this ID is an unique thing. So based on this ID, this is one table and this is another table. So based on this ID only, these two table can be related. So these are the general relational database structure. That's how it is created. And here the normalization also happens to store the data in a very efficient way. So the relational database structure is one of the good database structure. So next one is object oriented database structure. It is a system where information or data is represented in the form of object. So it is the combination of relational database structure and object oriented principles that happens in the computer science thing. So relational database concepts are concurrency control and transaction, based on the concurrency and transactions. So these are the DBMS structures or database structures that are related. How it is related to GIS, that we shall see in the next upcoming slides. So now let us see the DBMS capabilities or functions. So these are all I have already told you the features of databases. So based on that, what are the function and what are the capabilities our DBMS should have. That's why we are not relying on the file based system. That's why the DBMS is better than the normal file based system. So these are the capabilities or functions of DBMS that you can go through. So how can we query something, or what are the languages based on which languages we can create a DBMS structure or fetch the required information from our DBMS. So you can see there are some languages are here. Data definition language. So create, drop, alter and comment and rename, these are the data definition language. And DQL means the data query language, and DML the data manipulation language, and DCL data control language, and TCL is the transaction control languages. So these are the basic DBMS languages that you have to know for the examination point of view. So let us see the GIS database structure and GIS database indexing. So GIS database can be divided into two types, that is the spatial database, and another one is non-spatial, that is actually the attribute database. So we have already talked about the network data structure, hierarchical data structure, network data structure, relational data structure and object oriented. So this is a hierarchical network database structure for GIS. So this one is representing one map. So in this map there are two polygons, one is 1 and 2, those two are the polygons, and this is the typical hierarchical database structure for GIS database. And these are the lines. So these lines are dependent on this polygon, because this polygon is created based on these 4 lines, and these 4 lines are, each of the lines are created with 2 points. These are 1, 2. A is created based on 1 and 2 point, you can see here, and the polygon 1 is created by A, B, C and D, these 4 lines. So this is the hierarchical database structure. So next one is the network database structure. So as you know, the hierarchical database structure, the redundancy is higher, because here you can see the C is taken twice, here one C and here one C. So it has the higher data redundancy, so data has the higher size. So in the storage is not optimized. So next one is the network database structure. So in network database structure, there can be many to many relationship can exist, that one child may have 2 parents. So if because of this many to many relationship, this C line is dependent on both the polygon 1 and 2. Here you can see the C line is sharing with the polygon 1 and 2. So C is taken only once in network database structure. So data redundancy is reduced in network database structure. So let us see another important type of data structure, that is relational data structure. So in relational data structure, you can see there is one map is there, and map is represented by 2 polygon 1 and 2, and this one polygon is represented by 4 lines. Those are A, B, C and D. C is common to both the polygons 1 and 2. So 4 lines are represented here by one polygon, and each lines have the points. You can see A is created by 1 and 2 points. So this is the normal data structure of relational data structure. Now if we normalize this data structure to store in a efficient way, that can be done in relational database structure. So we can find out that map is represented by 2 polygons, that is okay, and map the 2 polygons are represented by only 2 lines. There are 4 lines are there, but it can be represented by 2 lines only. One is A. So what happens here, this line is considered as one line, and C is common to both. So C is another line. So this is the C line, and the polygon 2 is represented by C and B. So this line will be considered as the B line. So and so there are 3 lines only. Before there were A, B, C, D and E, F, G. There are 4 and 3, 7 lines were there, but here only the same map can be represented by only 3 lines, and A point is created based on 4 points. A line is created based on 4 points. Those are 4, 1, 2 and 3. B is created by 4 points. Those are 3, 5, 6 and 4. You can see here. And C is created by 3 and 4 only. So that is how in the GIS data structure is created and represented. So you can see one is hierarchical, another one is network, and another one is this relational database structure. To efficiently query the data, we can also index the GIS database structure. So there are 3 types of indexing. One is B-tree indexing, one is grid indexing, and another one is R-tree indexing. So what are those indexing? So B-tree indexing is the normal indexing that based on the alphabetical order. So A to F, and then those are segregated, and then the which is represented what is here in B-tree indexing. Another type of interesting representation of indexing is the grid indexing. So the map is divided into grids. First the grid is created based on the 4 pixels, and then another 4 pixels, A, B, C and D, and each pixel each pixels are divided into another 4 pixels. So after that the features are represented. So this feature you can see here, there are 3 features are there. One is feature 1, that is this one is the feature 1, this is the feature 2, and this is the feature 3. So feature 1 is represented based on that indexing here. So you can see that index A contains all the features. Feature 3, feature 1, this is the feature 1, and feature 2. So index A has all the features. Index B has only the feature number 3, and index C, where is index C? That is the C. It has only the feature number 1. And here if we go for the mode, this is the cursor, A, B, C, D, these are the cursor, and if we go for the finer indexing, then we can see the number 1 grid that contains only one feature, that is the feature number 2. These are representing the feature numbers. And these are the indexes, grid index. So that's how the grid indexing works. Another type of indexing is the R-tree indexing. In R-tree indexing, here bounding box is created. Based on the bounding box, the feature is indexed. So there A bounding box, B and C, 3 bounding boxes are there, and in that A bounding box there are D, E, F and G, 4 features are there, and B bounding box G, J, K, L, H, these features are there. So you can see in A bounding box D, E, F, G, and in B H, I, J, K, these features are there, and there is the C bounding box, there L, M, N features are there, and in A and B the G feature is common to both A and B. This feature is common to both A and B bounding boxes. So that is how the indexing is done in GIS database structures. So let us move to the next slide, that is the GIS database capabilities. So you have already seen the database structures and DBMS, what is DBMS and how in GIS the database structures are created. So what are the capabilities of this GIS database structure? So first one is the data capture. So data can be captured from various sources, like from maps, from satellite data, from digital data, from any attribute or tabular data, or you can create one soft ideas and you can code it like in computer programming, and based on that you can create another type of data. So those are the thing that can be done in GIS. So this is one of the capability, data capture and input. Another one is data management. You can link the attribute data with the spatial data that I have already shown you based on the GIS structure, and you can import or export in the GIS DBMS structure. So one geo server is there, that is one of the database structure for GIS, and you can combine map sheets and create large databases and match the edges neighboring map sheet based on changing the projection or various manipulation technique. So another one is the manipulation, that transformation of coordinate, that is the georeferencing, and change the projection to combine the map sheets. So both are interrelated, the management and manipulation. And then the analysis. So we shall come into those analysis part because in elaborate way, because the analysis is in our syllabus. The various types of analysis are interpolation, buffer, overlay analysis, terrain modeling, and network analysis, that we will see in the upcoming videos. Another one is modeling. So after creating everything, you have to model those things, that if anywhere the urban growth is happening, so what will be the urban growth down the line of 20 years or 30 years. So that you can model using the GIS thing. So that is one of the important capability of the GIS database structure. Another one is the display. Ultimately you have to display it to anyone. So you can export those thing in map format, in PDF format, or any various types of format to show it to anyone you want to show it. So these are the 6 GIS database capabilities you can go through. So that's all for this video, and